Hello and welcome. Today we're going to look at manipulating quadratic and exponential equations. This is another video on the Passport to Advanced Mathematics, and as always, we're going to be looking at 5 questions and explaining them, looking at the intricacies in this topic to help you ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started. Question number 1. The hang time of a football is the amount of time the football stays in the air after being kicked. The height in meters of the football above the ground at time t can be modeled by the quadratic function h of t equals negative 4.9 t squared plus 19.6 t. Which of the following equivalent expressions displays the hang time of the football as a constant or coefficient? Well, displaying the hang time of the football as a constant or coefficient essentially means that if you plug in one of those constants or coefficients they're talking about, the whole thing is going to equal 0. Right? That way the height would be 0, and that would be where the football ends its amount of hang time because it's not on the ground. Right? So we can just start plugging in the constants we see. Right? And the first question I only see 2. In the first question I see 2. Second question I see 0 and 4, or not question. In the first one I see 2, second one I see 0 and 4, the third one I see 3, and in the fourth one I see 1. So we plug in 2, we're still left with the 19.6. So this does not work. Alright, let's look at answer choice. I plug in 0, I plug in 4, it gets 0 both times, so that seems to work. Wait, let's just check the other ones to be sure. We plug in 3 into here and C, and then this becomes 0, and this becomes not 0, and this is also not 0, and this is not going to cancel out. So this will not work either. And looking at our last one, we plug in the 1, and that's not going to work. You're going to add something positive to another positive thing, and that's definitely not going to be 0. So these two don't work. Our answer is B, because if we plug in, well, 0 is the initial, but if we plug in 4, we get that's the hang time. That's when it hits the ground again. So that is our answer. Let's move on. All right. Question number 2 is an umbrella sprinkler is positioned on a ceiling at a point whose x coordinate is 0. Negative values of x indicate distances in meters to the left of the position of the sprinkler, and positive values indicate distances to the right. The path of water from the sprinkler can be modeled by the quadratic function w of x equals negative 1/4 times x squared minus 12, where w of x is the height of the water in meters at position x. Which of the following equivalent expressions displays the height of the ceiling as a constant or coefficient? All right. How are we going to do this? Let's see. So, well, x squared is always positive or 0. So x squared minus 12 is always going to be negative 12 or greater than negative 12, which means that negative 1/4 of that is going to be 3 or less than 3. Right? So it's always going to be 3 or less than 3. Right? Which means that the maximum ceiling is going to be at 3. And which of these equations displays the number 3 as a constant or coefficient? It is answer choice A, and that is our answer. It displays the height of the ceiling, which is 3 meters as the ceiling, and we can see here that it's an equivalent expression, and we can see here that this occurs at the at where the x coordinate is 0, right? So where is the maximum? We're going to sprinkle right here. We plug in 0, and we get that our ceiling is just as we can see right here. And let's move on. All right. Question number 3, and here it is. That is modeling the area covered by moss using the following equation. A equals t squared plus 5.8 t plus 9.41, where A is the area covered in square centimeters. Negative values of t represent the number of days before on July 1st, 2014, and positive values of t represent the number of days after on July 1st, 2014. Which of the following equivalent expressions contains the number of days before On July 1st, 2014, as a constant coefficient of the smallest area of 1 square centimeter. All right, now we're trying to find the smallest area. So essentially, we're trying to find the vertex of the parabola. Say, since our a value, right? So we have like a x squared or a t squared. The a value here is just 1. It's just a monic quadratic. But the point that we really care about is that it's positive, so it's going to open up like this. So its lowest point is going to be at its vertex, right? Now its vertex, where is the vertex located? Well, the vertex is located at minus b over 2a. And that is where the vertex of the quadratic is located. So we can plug in a is 1 and b is 5.8 to get negative 5.8 over 2, which is negative 2.9. That's the x coordinate of the vertex at its lowest point. All right, now where can we find 2.9? The only place it appears is answer choice A. So that is our answer. And let's move on to the next question. All right, question number 4. Here it is. The break-even point for a company is the number of units sold other than 0 units, for which profit equals revenue minus cost equals 0. Production is profitable only when revenue is greater than cost. The monthly profit of a company selling X units is given by the quadratic function of negative 1 over 200 x squared plus 30x. 30. Show the following expressions. Displays the break-even point as a constant or coefficient. Well, what is the break-even point? Let's find that out first. So this is equal to 0, so we can move this other side, and 30x is going to equal 1 over 200 x squared. Since we're trying to find the x value that's not 0, we can divide by x. Get 30 equals 1 over 200x. Multiply by 200 on both sides to get that x equals 6,000. So our break-even point is at 6,000 units. That's what we're trying to find. And now which of these contains 6,000 units? That would be choice D, so that is our answer. And let's move on. Question number 5, here it is. The height h in feet of a baseball t seconds after Tobin hit it with a baseball. If we modify the equation below, h of t equals negative 16t squared plus 64t plus 4. And we're asked to find which of the following equivalent expressions display the value of the baseball's maximum height as a constant or coefficient. First, let's find out where the maximum height occurs. And then we can find out what the maximum height actually is. Well, since this is going to have a negative a, it's going to open down like this. So its maximum point is going to be up here at its vertex, which is still negative b over 2a. And for this question, negative b over 2a is going to be negative 64 over 2 times negative 16. So the negatives are going to cancel, and we're just left with 2 as the x coordinate of the vertex. That's where the maximum occurs. And I plug this in to get h of 2 equals negative 64 plus 128 plus 4, which is going to equal 68. So we're trying to find the 68 as that is the maximum height, and we see that in answer choice A, that is the maximum height, and we can see it in the question as a constant. So our answer is A. That is it for this topic. As you can see, it's mostly just about taking these quadratics in and then being able to understand what it's saying, what they're trying to get at, and manipulating them, understanding the meaning of these expressions, and that's really what we're doing here. Stay tuned for next time we continue on the Passport of Advanced Mathematics, and I'll see you later.